morning, grade 10s. It is Monday. It's 8 in the morning. Good to see you. I hope you had a good weekend. I will be doing the first section of the next unit, which is linear systems. There's nothing really new again. It's we'll do some graphing and some algebra. There's just a new thing you can do with algebra that we haven't done yet. Okay, so let's get down to it. So here we are on page 186 or page 171, depending on which book you are in. And let's get down to business. A system of equations. Now, that's a new sounding thing, and it sounds a little scary, but it's not, of course. A system of equations is a group of at least, and please understand it's at least, two equations which may share a solution. All right, so that's the first thing you have to know, what a system is. If I have two equations, they may share a solution. Let me give you an example. X plus 3 equals 5. And x minus 7 equals negative 5. And if you did those, oh, my little dot's missing. Sorry. There it is. Come on. There we go. Sorry. So if you did that work, you would see that x equaled 2. And that's what I mean by they may share a solution. It's entirely possible that they won't. But for our intents and purposes, they are going to. I'm sorry all this is going on. I just want to... screw it, I'll do this later. So, a linear equation, which we've been working with this entire last term, is very simple, is mathematical representation of a line on a graph. We've seen these all the way through. There's 4 ways we can write it. There's y equals mx plus b. There's y minus y1 equals mx minus x1. There's ax plus by plus c equals 0. And ax plus by equals c. All these things share the characteristics that they will, when we write them in algebra and we apply algebra to them, we can graph a line. A linear system, therefore, must be a system comprised of only linear equations. So, and lastly, to solve a linear system, means to find the coordinates which appear on both. Oh wait, I don't want to say both because we might have more than two. On all the lines. So as soon as I see coordinates, I know I'm looking for x's and y's. Now here's what I mean. I'm going to slide over here. I'm going to draw a Cartesian plane, and I'm going to draw a blue line. Now that line has a y equals mx plus b, a y equals y minus y equals mx minus x. It's got they're all the same. This has an equation, right? And that equation, every single point on that equation is an x and a y. All of you should understand that. Now, if I draw another line, all of those points are also an x and a y. So all of these blue points and all of these red points are solutions to the red line and the blue line. Now what do you notice right here? That purple xy is on the red line and the blue line. So that is the solution to the system. Alrighty? So let's get down to it. You're going to learn 3 ways to do this. The first one we're going to learn is graphing. Now, graphing is often the least reliable, but that's okay. You should learn it. Okay, so when we're going to solve by graphing, the key, as we said, is to find when the lines cross, like in Ghostbusters, except this time we want to cross the lines. We don't want to avoid it. So there's a simple set of steps. All you do is these 3 things in a row. So step 1, get it into slope-intercept form. So this means we use algebra to isolate y. Once y is isolated, we have this, and we can put it in. We can put it on a graph. Remember, m is the slope, and b is the y-intercept. Then you graph them, and then all you do is find where they cross. That's it. 3 steps for each line. Well, actually, 2 steps for each line, and the 3rd step covers both of them. So let's try one. So here's our first one. I'm going to go ahead and put an x and a y on here. I don't know why I printed these books without axes, but I did. Whatever. So I'm going to make the red line x plus y equals 4. Now you're smart kids, that's not in slope-intercept form. So we'll take x plus y equals 4, and we'll isolate y. So y equals, I bring the x over, negative x plus 4, which means I go to 1, 2, 3, 4, negative 1 slope, so down 1, and right 1, because I want my slope negative. And in this case, you can see I'm only putting dots, because while we're learning, the answer to the solution is always going to be what is called a cardinal point, which is a point that has a definite x and a y. But that's why graphing is not necessarily the best way to solve a system, because of course they don't always cross, because as you all remember, there's an infinite number of answers between 0 and 1. But that's okay. For learning, we're going to do it this way. And here's the blue one. negative x plus 2y equals 2. And again, y is not isolated. 2 equals x plus 2, 2y. Divide everything by 2. Y equals 1/2 x plus 1. So here I go to, there's 1, and then it's positive 1/2, so it's up 1, right 2. Oh, and look, there's where it crosses. And so, red, blue make purple. That purple dot right there is 2, 2. And that's the solution. Now, everybody always says, and you know I do this joke all the time, mathematics, I do it right, Of course you can check it. I have an answer here. All you do, that is an x, that is a y. Test it. Is 2 plus 2 4? Yes. Is negative 2 plus 2 times y, which is 4. Is negative 2 plus 4 2? Yes. So I know I did it right. So here's a second one. Oh, I've made my axes purple, but that's okay. We can work with that. So here's the first one in red again. 3x minus 2y equals 12. Negative 2y equals negative 3x plus 12. Y equals 3 over 2x minus 6. There's our first one. Here's our second one. 2x plus y equals 1. Y equals negative 2x plus 1. And then I graph them. Plus 1, negative 2, down 2, right 1, down 2, right 1, down 2, right 1. Or up 2, left 1, up 2, left 1, up 2, left 1, and so on. In red, negative 6, I'm way down here. 1, 2, 3, 4, 5, 6. But my slope is positive 3 over 2. 1, 2, 3, 1, 2. Oh, look. There's the crossing point. And that right there, ladies and gentlemen, you can see is 2, negative 3. So then, all I got to do is check. Excuse me, my phone is ringing. Is 6 plus 6 12? Yep. Is 4 plus negative 3 1? Yep. So I know I did it right. Okay, and the last one. Now this one you'll notice something weird, something most of you probably haven't seen before. Those weird square or straight line bracket things around. What the heck? Why aren't I getting my... I gotta close out. All right. I don't want to make this a whole lesson on this. I just want to show you. These weird bracket things are pretty easy. All it means, they're called absolute value brackets. 0. So here's a number line. 1, 2, 3. That point right there is 3 steps away from 0. Y'all know that. Here is negative 3. Also 3 steps away from 0. Absolute value is a measure of this distance, whatever it is, how far you are from 0. So even though this is in a negative direction, the absolute value here is still 3. It just can't be negative. It's that simple. So if I was going to graph this y equals x, it's already in slope-intercept form. It's got a y-intercept of 0 and a slope of 1. So it's pretty easy to see that it's going to go off this way, right? When y is 1, x is 1, because y equals x. But if x is negative 1, then you'd have the absolute value of negative 1. Well, that's right here. But see, it's only one step away from 0. So y stays positive. So these absolute graph things, absolute value graphs, actually make two lines that are a reflection of each other. They bounce off the y-axis. Now, that's not really part of grade 10. I'm just showing you for what's about to happen. Here is already in y-intercept, slope-intercept form. So 1, 2, 3. And it's got a slope of 1/2. So up 1 over 2, up 1 over 2, up 1 over 2. Oh, look, it hits right there. But down 1, left 2, it also hits right there. So it, as you can see, I've got two values, 6, 6, and negative 2, 2. So let's check. If I put 6 in for x, the absolute value of 6 is 6. It's 6 away, right? So that one works. If I put negative 2 in for x, the absolute value of negative 2 is right there. Is that 2 steps from 0? Yeah. So y was 2, so it works. Half of 6 plus 3. Half of 6 is 3. 3 plus 3 is 6, so it works there too. Half of negative 2 is negative 1. Negative 1 plus 3 is positive 2, so it works there. So why did I show you this? I showed you it just to prove this point. No matter what the graph looks like, even if it doesn't make a single straight line, anytime graphs cross, that's a solution. So next year in grade 11, you'll be having things like a curve with a line. Two solutions. You might have a curve with a second curve. Two solutions, right? You might have 3 things on a graph, right? There's a solution, but it's not all 3. There's a solution, but it's not all 3. There's a solution, but it's not all 3. You see what I'm saying? I'm just preparing you. All right, that's the end of the video. Page 188 or page 173 is what you need to do for Wednesday. Thanks, everyone. See you later.